SSH or Secure Shell is a protocol just like HTTP or HTTPS that allows one computer to communicate with another. In this video, you will learn what SSH is, how to clone GitHub repositories using SSH, how to connect to a server using SSH, and as a bonus, we will deploy a React app in our server using NGINX. So be with me. Okay, protocols like HTTP, HTTPS, FTP, and SSH work between at least one server and one client, which means you need at least one server and one client to use these protocols. HTTP or Hypertext Transfer Protocol, for example, allows you to send files like HTML, CSS, and JavaScript from a server to a client using browsers. FTP or File Transfer Protocol allows you to upload files from a client to a server. HTTPS is just like HTTP, but it's encrypted and more secure. And using SSH or Secure Shell, we can run shell commands, share files from a laptop, for example in London as a client, to a server in the US in a secure way. And if you know commands, then you know you can do almost anything when you can run commands on a computer. So to communicate with a server using browsers, we use HTTP. To do that in a secure way, we use HTTPS. But for shell, we have SSH. And shells allow you to control your operating system by entering commands. So SSH is the way to connect to your server, control it, configure it, run commands on it, etc. But why do we need to use SSH? Because it's secure and fast enough to communicate with your server. Well, why do we need it to be secure? Well, imagine that you have lots of important stuff on a server. For example, your website is running on it and you have people's data on your website. That's important, right? You try to manage your data on that server using commands. For example, just consider this as a command. We want to get one of our users' email address, so we happily run this command on our server. Data.get to get the data from users.ali.email, because we want Ali's email address, but somehow a person out of nowhere that is certainly not our friend stands in the middle between you and your server and somehow changes this command to something like this: data.send to send the data from this command, data.get users.ali.password to get Ali's password and send it to his email address, for example hacker@hackeremail.com. Of course, this is just an example. We know that passwords are encrypted, but this way the hacker guy, which is in our case the bad guy, now knows Ali's password, and that's not what we want, because data is very important. We should be careful about the data we have, the data we're responsible for. Okay, with something like SSH, we can prevent something like that, because it's encrypted and very secure. With SSH, you can even use something called pair keys for its encryption, a private key and a public key. Okay, to understand pair keys encryption, you need to be familiar with the symmetric and asymmetric encryption. Symmetric encryption uses one secret key for both encryption and decryption, a lock with one keyhole. You encrypt your file with a key, then you send the file to someone that will use the same key to decrypt the file. So this way, if someone somehow gets your file that you don't want him or her to have it, well, it's encrypted. He or she will only get a gibberish, useless file. But what if someone somehow finds our key? Because in this case, anyone that has the key can access that file's content, right? For example, you send hello as a secret message to one of your friends. You used key 1 to encrypt that message. In symmetrical encryption, you also need to send key 1 for your friend, so he or she can decrypt it. Well, this way, if someone somehow gets your key, someone that's not supposed to have it, for example, you email it to the wrong person, if we consider that your email was also encrypted and it was safe, then boom, your message is no longer secure. So at this moment, we have a way to encrypt our files and data. So if our files got to the wrong hand, we won't worry about it, because it's gibberish and useless for that person, because he or she hasn't the key yet. But we still need a way to be sure that if somehow our key was also leaked, our file still is secure. Well, that's exactly why we have asymmetric encryption. In asymmetric encryption, we have two types of keys. A public key, that is the key you share with your friends, like when you share your username, and it's okay. And a private key that you never share, like your password. Of course, it's not correct to call them username and password. I'm just saying it like this for you to understand them better. So public key will encrypt the data, and only the matching private key can be used to decrypt it. Not even the person who encrypted with the public key. So if you know someone's public key, you cannot achieve his private key. It's like a lock with two keyholes, one to lock and one to unlock. So for example, if you want to send hello to your friend Ali, use his shared key, which is his public key, to encrypt the message. And then if he wants to decrypt it, he can use his private key to decrypt it. So this way, even you can't read the message anymore. Only who has the right key, which is Ali's private key, by the way, can decrypt the message. That's why in this scenario, the private key is really important. You should never ever show or send it to someone, even your friends. Asymmetric encryption is used in a lot of places, like when you visit a website that uses HTTPS, or in Bitcoin, and of course in SSH protocol. To use SSH, we need to have at least one server and one client. So you need to install software on both your local computer and your server. If you're not trying to use SSH for a home server and you want to pay for a server from websites like Digitalocean, then you probably don't need to install software on your server. It's already there, activated and ready to use. So let's create a server in the Digitalocean website. To create a server, go to Digitalocean website, create an account. After that, create a server, or as they call it, a droplet. Okay, choose your distro. I'm gonna go with Ubuntu. Then choose your plan, which for this video, the cheapest one is enough. But I'm gonna choose Premium AMD. I just like it that way. You can go with any of these you want. I don't need extra storage. Choose your location. I'm gonna go with London. Okay, this is fine. Fine. Now here we can choose we want to log in to our server using a password or SSH keys. SSH keys are more secure, but I'm gonna go with password just to show you how you can configure SSH keys on your server and disable the password authentication by yourself. Okay, name's fine. It's actually not fine, but who cares? Okay, wait for a few seconds. Then done. Copy this IP address. Okay, now here we need to have SSH software on our client side. To use SSH, well, if you're using Mac or one of the Linux distros, then you probably have the SSH software you need. To check that, open your terminal and type SSH. As you can see, I already have it because my terminal recognizes it, but if you don't have it, you can install it for your operating system. I'm sure it's available on most Mac computers, but on Linux, hope you know how to install it. But if you're using Ubuntu or other common distros, I'm sure they have the SSH installed when you install the OS. Remember, we're talking about the client side. Okay, about Windows. There are several ways to use SSH on a Windows machine. In newer versions, you don't even need to install something on your computer, but it sucks. I tried so many times, and each time I got a new problem. So I highly recommend other ways, using GUI apps like PuTTY, or use WSL, which is Windows subsystem for Linux, and it's great if you're using Windows 10. Or use Git Bash, which I highly recommend you to use this one. It will emulate the Unix environment for you, so you can run Unix commands on it. If you're comfortable with the command line and you know about WSL, then definitely go with WSL or Git Bash. I will put links for WSL, PuTTY and Git Bash in the description below. But if you're not comfortable with the command line, then you can use GUI apps like PuTTY, which is fine. It doesn't matter how you use SSH. But remember, you need to use the command line anyway, eventually, because we're using a Linux server, so you can ignore the use of command line in Windows, but when you've SSH to your server, you need to run commands on your server. So, okay, to download PuTTY, go to its website and download and install it on your machine. Then you can follow along with the stuff we're going to talk about, except you're using PuTTY, but I'm going to use my Mac terminal. Okay, let's copy the IP address again, just to be sure we have the right IP address. Okay, if you're using the command line, type SSH root at, then paste the IP address you've copied. Root as the default user, then hit enter. Okay, after you try to connect to a server for the first time, you will see something like this. So accept it by typing yes, then type the password you've set when creating the droplet or whatever. Sorry, somehow my terminal doesn't paste the password here, so let's do this one more time. Okay, we're now on our server. As you can see, it's showing us this user we entered, and the server's name is exactly that crazy name we saw on the DigitalOcean website. Now, there are several things you can do the first time you logged in to a server that I highly recommend you to do it. The first one is to update and upgrade it. So it's an Ubuntu server, so I type this command to update it. But if you're using other distros, you should search for that. Okay, app update to update the mirrors. Then, as you can see, it's saying that there are packages that can be upgraded, so let's upgrade them. App upgrade. Are you sure you want to upgrade? Yes, that's why I typed this. Y is capital, because if I hit enter, Y will be applied. So hit enter for Y, wait for a few seconds or minutes sometimes. Okay, then to make the server more secure, we can disable logging with the root user, because that's the first thing bad people use to attack the server. To prevent that, type add user, name of the user, just put a simple name here like Ali. Okay, type a password here for your user. Remember, it's important. Type that again. Okay, then you can put some information about the user here, but I don't want to, so I just skip this by hitting enter. So enter, 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 and enter. Is this correct? I guess so. So enter one more time. Okay, to check the new user, type cat/etc/passwd. Okay, it's here. Now this user should have access to the sudo command, so let's configure that. To check we have the sudo command installed, type which sudo. If you don't have it, you can install it this way if you're using Ubuntu. Type app install sudo. with your root user. But why? Just type this vi sudo. Okay, it uses nano by default as the editor because we didn't configure it, but it's okay. As you can see, sudo users can execute any command, and that's what we want for our user. A person sign means it's a group, not a user. Okay, Control X to quit, and then type this to add sudo privileges for our user. User mode -A capital G to add the user to sudo group. Now which user? Well, Ali. If you're on CentOS or something like that, it's the will group or admin instead of sudo. Okay, to check this real quick, type groups Ali. Great. Now open a new tab on your local computer, on your terminal or PuTTY, then try to connect to that user instead of root. So SSH Ali at your IP address. Then type the password we used for Ali, not the password we used to create the server. Now we can switch the user to root again. To do that, type sudo su space dash. Type your new user's password again, then who am I and pwd. As you see, we are now the root user at the root directory. To get back to Ali, type su. We don't need sudo because we're root now. Then dash and Ali. Okay, who am I and pwd. Okay, I'm Ali now on Ali's home directory. Now that our new user has root privileges and we're positive that we can SSH to the server using that user, then we can disable root login. To do that, type sudo vim. I use vim to edit files here, but you can use nano too. /etc/ssh/sshd_config. Then search for permit root login by typing / then permit. As you see, it's set to yes. To disable it, type no. To do that, press I to get to the insert mode, then change it to no, then hit the escape key to get back to normal mode, and type :WQ and hit enter to save and quit the file. Okay, each time we change something here in the SSH config file, we need to reload the SSH daemon for our changes to be applied. So sudo systemctl reload sshd. Remember, it's not SSH, it's SSH daemon. We can use the restart parameter too, but I don't recommend it, especially if you're running something on your server and users are using your server. Now, exit to get back to your local computer, or you can open a new tab, and this time try to log in to the root user. So SSH root add server. Type the root password. Now, as you can see, it won't let us log in to the root user. Okay, there are lots of ways to make your server more secure, but there's no end to security. And that's beyond the scope of this video. But if you're responsible for a server, there are 3 things you should always do. 1, keep your server up to date. 2, don't use the root user, and don't use passwords to log in via SSH, because that way, if someone knows your password, then he or she can easily log in to your server and do stuff that you may not want. So as I said, you can use pair keys with SSH, a private key and a public key. To create them, exit from the server, then open your terminal or command prompt on Windows or git bash, then type ssh-keygen -t for type. Then we have several options for the type of the algorithm, like RSA, usually with the length of 1496, B is for bytes, or DSA, which is old, so I don't recommend it. We have ECDSA, usually with the length of 521, supported on most of the servers and client softwares and websites like GitHub. Then we have ED25519, which is newer than ECDSA. So before actually using it, check the documentation. Here I'm going to use ED25519 -C for comment. If you're using multiple SSH keys for multiple purposes, I highly recommend you don't use one key for several purposes, and don't copy your private key to your new devices. Just create a new one. This way, if a key leaks, you know which computer is compromised. For example, one for GitHub, one for your server, and one for GitLab. Usually I will put the server's name and the user in the comment. So Ali at the IP address or the domain, if you have a domain. So SSH-keygen-t at 25519-C Ali at the IP address we have. Now this command will generate both our public and private key that will be saved here in our current user home directory, and its name is id_ed25519. To change the address or the name, just type it like /users /your name /.ssh, then the name that you want for your keys. If you want it to be more secure, then put a passphrase here. If you don't like a passphrase, just hit enter and skip this, but I highly recommend you to use a passphrase. Type that again. Okay, now we've created both our public and private keys. To check that real quick, let's go to our SSH directory, so cd.ssh and do a ls. Okay, this one here is our public key, the one we share with people, and this one is the private key. This belongs only to this computer, and we should never ever share the private key. cd to get back to the home directory. Okay, now to use our keys to connect to our server, we should copy the public key from here to a file named authorized keys in the SSH directory in our user home directory in our server. So if you have SSH copy ID command, you can type ssh-copy-id-i, then the path to your public key. Remember, we should copy the public key to our server. So /id_@25519_ Then your user, so user at then the IP or domain address. But if you don't have it, you can use SCP, like scp.ssh/id, then your public key, user at server, then the path to authorized keys file. Or without any tools, just type this. So cat.ssh, the path to our public key, id_@25519_digitalocean.pub, pipe to pass the output of the cat command to SSH user at server. Quotations. Here we can put commands that we want to run on our server. So make directory -p //.ssh and chmod 700 //.ssh and cat 2 greater than signs //.ssh authorized keys. And yes, then type your user's password. Okay, then SSH to the server. So SSH ali at IP. Type your user's password, then let's see what we have in the authorized keys. So cat.ssh authorized keys. Okay, this is exactly the key we have in our SSH directory. You can check that if you want. Okay, now we need to disable the password authentication, so we need to change the SSH config file again. So sudo, remember to edit it with sudo privileges, then vim /etc/ssh/sshd_config. Okay, there are several things that it's good to disable them. So find challenge response authentication and set it to no, then password authentication, no. Okay, then use spam and no. Okay, hit the escape key and colon W and Q to save and quit. Okay, let's reload the SSH daemon. So sudo systemctl reload sshd. Okay, now without closing this tab, open a new tab in your terminal. Then to test the SSH keys, type SSH ali, your user, and the IP address. Okay, if you're seeing something like this, like permission denied, public key, do this. We're seeing this because the SSH agent could not find the right private key. Sometimes it happens. You can check the public keys SSH agent knows like this: SSH-add-L. So nothing's here. So let's add our private key to the SSH agent. So ssh-add.ssh/id_ed25519_Digitalocean, and that's right. By this, we add our private key to the SSH agent. So remember that. Then let's try to SSH to the server one more time. So SSH your user and the IP address, and tada, that's it. As you saw, it didn't ask for a password. Now we can do stuff on our server, transfer files or deploy our website on it. To send files to our server from your local computer, if you like GUI apps, you can use FileZilla or Cyberduck or anything that supports the SFTP protocol, which is SSH File Transfer Protocol. Or if you're comfortable with the terminal, you can use SCP, RSYNC, or SFTP. Now in this video, I'm going to show you how to transfer your files using a GUI app, which is Cyberduck, and in SCP, RSYNC, and SFTP. So now, this is Cyberduck. I will put its download link in the description below. Now to connect to your server, click here to open a connection. Change the protocol to SFTP, which is SSH File Transfer Protocol again. Port 22. Paste your server's IP here and the username, which for me is Ali. We don't need to put a password here because we configured the server to use the SSH keys instead of the user's password. But if you use password authentication for your server, you should type the password here. So I don't type anything here, and from here choose your private key. So id_ed25519_Digitalocean, and that's it. Click here to connect. Click on allow. Okay, here's our server. Now let's create a new file here, hello for example. So new file, hello.txt. Okay, now if I can just drag it from here and drop it here on my desktop. Now as you can see, it is downloading. Now it's on my desktop. Now I can open it with a text editor and type something here. So hello from the local machine, and we're using Cyberduck. Okay, save and close. Now I can send it back to the server this way, and it's asking me if I want to overwrite. Yes, so continue. Okay, completed. Now let's get back to the terminal and do a ls on the server and cat hello.txt. Wow, as you can see, it's here. It's like this because end of the line issue, because end of lines are different in different operating systems. If I open it with Vim, we can see that it's okay. So Vim hello.txt, and it's okay. Now let's do what we just did with SCP, or secure copy. But note that according to OpenSSH developers, which is the software we use to connect via SSH, in April 2019 SCP is outdated, but I'm still going to talk about it and show you how to use it. Why? Because first of all, a lot of people are still using it. So after this video, if you see someone is using SCP to send files through SSH, you know what it is. And second of all, OpenSSH developers recommended us to use things like RSYNC or SFTP, and RSYNC is just like SCP. So if we know how to use SCP, we will be comfortable using RSYNC too. Here on the server, let's change hello.txt a bit. So this is what we typed before. So hit O for a new line, then type hello from the server. Escape :WQ to save and quit. Now, SCP is working like this: SCP source destination. So now to copy this from here to our local machine, on a new tab, type SCP to copy, then the source, which is ali@server, then the path to our file. So :home/ali/hello.txt, then the destination, which is my desktop. So okay, now if I open this up again with our text editor, as you see, it has the text we typed on the server. So now I can easily add a new line here. So hello from the local machine, and we're using SCP. Save and close and get back to the terminal. Now to copy the new version of that file to the server, type this: SCP. This time our source is our local machine. So ~/desktop hello.txt to our server. So ali@server in our user's home directory. So :home/ali/hello.txt. Here on the server, if I type cat hello.txt to print out this file's content, okay, it has the last change. It means we've successfully overridden this file from our local machine. So remember that it will overwrite files. Okay, that's enough for the SCP command. Let's use rsync for transferring files. To use rsync to send out our hello file to our local machine, let's first edit the file. So vim hello.txt. Okay, if you use Vim to edit the file like me, type O for a new line, then type hello from the server. This time rsync. Escape :WQ to save and quit, then go to your local machine and type rsync -P to see the process, because by default rsync wouldn't show us the process. Then the source, just like SCP, which is our server. So ali@server :home/ali/hello.txt, then the destination, which is our desktop on our local machine. So ~/desktop. Now if I check the file again, oh yeah, it's here. As you saw, it was just like SCP. As a practice, type something in the file and send it back to the server. But SFTP, it's a bit different. It has kinda its own syntax and commands, but it's still really simple. So on your local machine, type cd desktop to go to desktop, then SFTP ali at then the IP address. Okay, we're now on the server. It's very easy actually. Look, if I do a ls here, it will list the content of our user home directory on our server. If I type lls, which is the local list, it will list the directory content on our local computer, the directory that we type SFTP there, which was our desktop. So ls for server, lls or local ls for our local machine. And just like this, cd.ssh will change the current directory path to .ssh directory on our server. To check it, type pwd. As you see, it's saying remote working directory. And cd to get back to the home directory. On the other hand, if I type lcd tilde /.ssh, it will change the current directory path to .ssh directory on our server. To check it, type lpwd. So lcd tilde /desktop to get back to the desktop. Okay, if I add another line to the hello file, so hello from the local machine, and we are using SFTP this time, then save and close the file now. To put this new version of the file into our server, we can type this put hello.txt, and that's enough. It will search for this file in our desktop directory on our local machine, and if it was there, which it is, it will upload that file to our current remote directory on our server, which is our user's home directory. Okay, let's check that real quick. So vim hello.txt. Okay, it worked. Now let's add a new line. So hello from the server SFTP, hit escape, then :wq to save and quit. Now to copy this newer version to our local machine, get back to SFTP, then type get hello.txt. If you're on desktop, you can always change the local and remote paths using the cd command. Okay, now if I hit enter, it will fetch the file from the server to my desktop on my local computer. Okay, now we can type bye to close the SFTP session. There are a few other commands that I didn't talk about, like rm to delete a file from our server, or rm directory to remove a directory from our server, or make directory to make a directory on our server. And you can even type help. Let's do that real quick. SFTP alley adds the IP address. Help to see all of the commands we can use, but I'll leave the rest for you to try out and have fun. Now, as you saw, there are lots of things we can do with SSH on a server. We can send files to our server using SSH, we can get files from our server using SSH, or we can deploy our website on a server using SSH. So let's do that. To deploy websites, we need files like index.html, production stuff, and it should be optimized for production and deployment. And to get those files from a React project, we need to install nodeJS on our server so we can build the app and get those files. Then we need a web server like NGINX or Apache to actually run the website on our server. So first, let's install nodeJS and npm on our Ubuntu server. To do that, type curl or curl -s capital L https://deb.nodesource.com/setup_14.x pipe sudo capital E bash space dash. Type your user's password. Okay, then sudo apt install node.js. Okay, now if I type node --version and npm --version, so now we have both node and npm. So type npm init react-app my app to create a React application. Now let's build it. So cd my app, then npm run build to build the project. Okay, if we do another ls, here now we have a build directory, and if I list this directory's content, so ls build, as you see, it has our index.html, which is what we want to deploy this project. But to deploy it, we need a web server software too, like Apache or NGINX. And in this video, I'm going to use NGINX. So let's install it. To install it from its source code, type cd to get to the home directory, then wget https://nginx.org keys nginx _signing.key and sudo apt-key add nginx _signing.key, type your password, then type sudo vim /etc/apt/sources.list.d for directory /nginx.list. Hit I for insert mode, then add this line deb for Debian systems and arch equals amd64 https://nginx.org packages mainline Ubuntu, then your distro code name, which for Ubuntu 2004 is focal, then type nginx, escape, then :wq to save and quit. Then we need to update the mirrors, so sudo apt update. Then finally we can install nginx, so sudo apt install nginx. Just remember, all the stuff we talked about are for Ubuntu 2004, so if you're using other distros like CentOS or older versions of Ubuntu, then you need to search for the commands for your distribution. Let's check if nginx is activated. So sudo systemctl status nginx. If it's inactive like me, do this: sudo systemctl start nginx. Let's check the status one more time. Sudo systemctl status nginx. Now to enable it, so it will be activated even if you restart the system, type this: sudo systemctl enable nginx. Now if I go to my browser and type the server's IP address here, wow, as you see, this is the nginx default page. We can put our index.html here, the one we have in the build directory in our React app instead of this page. So let's configure nginx to do that. To do that, we need to go to NGINX Configuration directory, which is in the etc directory, just like most of the Linux configuration files. So cd/etc/nginx/conf.d for directory, ls to list. This is the default. Let's open this with vim real quick. Vim default.conf. This is our default configuration. This is where the default page is and other stuff. By default, nginx will use every .conf file here. So let's create one for our website. But before that, we can remove this file or just rename it to something else, something that doesn't end with .conf. So hit escape and :q to quit from here, then type move default.conf to default.conf.origin. Do this with sudo, so sudo default.conf default.conf.origin ls. Then let's create a new one, so sudo vim for our React app, which is myapp.conf. Then let's add a server block here, so I to get into the insert mode, to type here, then server left curly bracket, listen to port 80, then for IPv6 listen : 80. Now let's set a name for this. You should put the IP or domain address here if you have one. So server _name like example.com, but I'm gonna use the IP. Then location, this is for the root path of the website. So slash left curly bracket root, then the path to our static files, which is home, ally, my app, build. Usually people create a new directory for the static files, but just to show you guys how people do that, this is enough, I guess. And which file is our index file? So index, look for index.html, and if it wasn't there, then look for index.html. Then to test our configuration, type sudo nginx-t. This is for the default configuration that nginx has. Okay, then sudo nginx-s reload. Okay, now if I paste the IP address on my browser, and ta-da, this is our website. Let's change this text a bit and build the project again. So get back here on the server, then cd home my app. Let's edit the text we have on the main page. So vim source app.js. Then let's change this to hello. So hello. Okay, escape :wq to save and quit. Then npm run build to build the project again. Now if I check this again, yes, it is working. As you saw, we can now send this directory to our local machine using the tools we talked about before. But there are files that we don't need, like the build directory or node modules, because we can create them easily later by npm install or npm run build like we did before. So we can create a new repository on GitHub, push these files there, and ignore the files and directories we don't want using that gitignore file, which we already have that file. Look ls-a to see both normal and hidden files, and as you see, we have a file named .gitignore. So if I open it real quick, vim.gitignore, as you see, everything you see here will be ignored by Git. So they won't be on GitHub, and if we change them, Git just doesn't care. But to push these files to GitHub, we can use HTTPS and type our password every time we want to push or pull our changes to GitHub, because we're not going to always work with public repositories. In fact, most of the time, when we're using a server to host our website, we're doing it on a private repository, so we need our password for that. Or we can add a public SSH key to GitHub and use that for push or pull to a private repository. Well, we know that using a password is not a very good way, and it's tedious because we should type the password each time we push or pull to a private repository. So we can use SSH keys. But there's something that we should think about before do that. The question is, are we really want to add a private key to a server? I wish there was a way so I can just use the private keys I have on my local machine to push or pull the changes to GitHub. Well, be happy, because there is, and it's called agent forwarding. SSH agent is the thing that prevents us to type our passphrase every time we SSH to a server, and we can configure our SSH agent to forward it to our server. This way we can use our keys on our local machine to connect to a server we configured like GitHub on our server. Then we don't need to create SSH keys on our server, right? Let me show you how to do that. So go to GitHub, sign in, I already did, then create a new repository, name it whatever you want. So React starter code. I want this to be private to test our keys, and I don't need any of this. Then we need to add our public SSH key to GitHub. We can of course add our old keys to GitHub, but I highly recommend you to create multiple keys for multiple purposes, because this way if a key leaks, you'll know to worry about what, and you know which system is compromised. To do this, we need to give GitHub our public key, just like we did with the server. So for GitHub, let's create new SSH key. So we can clone the repo using SSH, push or pull our changes to our private repositories on GitHub without typing our password. So open a new tab, then type this on your terminal. SSH-keygen-t. This time let's use ECDSA-B, and for the length 521-C for the comment, quotations, Qurbanzadeh, which is my GitHub username, at github.com. Okay, slash users, slash your user, slash.ssh, and the name of your key. Remember, if you don't change the name and you've created SSH keys with this default name before, that will be overridden. Okay, then type a passphrase that I highly recommend doing so. Okay, done. Then cat.ssh, then the name of your public key. Copy the whole text, then log into your GitHub account, go to settings, and in the SSH and GPG keys, click on the new SSH key. Choose a title for it, then paste it here, then click on the add SSH key button, and done. It's here. It's never used. So let's use it to clone that repository. Then get back to your terminal and let's test that our SSH key is working by typing SSH-T git at github.com. If you're seeing this, just type SSH and then your private key. Then let's try that again. Now if you're seeing your GitHub username here, then it means it's working. So now we need to configure our SSH agent so we can use this key on our server too. So type code. You can use Vim, but because we're on our local machine and I have VS Code installed on my local machine, I use that just to show you guys that it's okay to use other editors too. .ssh/config. If you don't have this file, that's fine. Just create it with your favorite editor. Okay, here type your host that you want to forward into. So host, then the IP address. You can type your domain here too if you have one, like google.com, example.com, but because we don't have one, so I just type the IP address of my server. Then tab, then forward agent, then space, yes. Now let's SSH to our server again. So SSH ali at IP and test if it's working on our server too. So SSH-T git at github.com. Wow, it's working. And as you see, we don't have any keys here. So now let's push our app to GitHub. Back to this page and follow these steps. But before that, if you didn't configure your Git, do that. So I'm just gonna do mine real quick. So first let's check what version of Git we have here. So Git version, oh, this is pretty old. So we probably can't do a lot of new stuff here. So let's first install a new version of Git. This is actually why people use Docker when they want to create a droplet on Digitalocean. With that, we can do all of this stuff with less pain, but that's beyond the scope of this video. So to install the latest version of Git, go to this page. Then choose your operating system, so Linux, Ubuntu, okay. Then follow these steps. So sudo add apt repository ppa git-core ppa. Then sudo apt update to update our mirrors. Then sudo apt install git. Yes. Okay, now if I check the version again, git version, we can see that this is the latest version at the time I'm recording this video. Okay, now to configure Git, type git config --global, then user.name, then put your name here. For me is Ali. Then for email, git config --global user.email absolute code at protonmail.com. Change the directory to my app, then git init-b main. Then we can check the status. So git status. Okay, let's add them. Git add all of them. Okay, check the status again. So git status. Then let's commit what we have in the staging area. So git commit -m initial commit. Okay, now let's add our remote address. So git remote add origin, git add GitHub, absolute code, React, starter code .git. Now to push the changes, type git push -u origin main. Okay, let's check GitHub. Okay, it's here. Now we can clone it on our local machine using the same SSH keys. Look, let's open a new tab here, then let's go to the desktop. Okay, now git clone, git add GitHub, absolute code, React, starter code. Okay, let's cd there. So cd react starter code. Let's open this directory with VS Code. So code dot. Okay, now if I go to source, then app.js, you can see that this is our hello. Okay, that's enough. If you like this video, please consider hitting that like button and subscribe to my channel. But if you didn't, please tell me how I make better videos. Okay, thanks for being with me so far, and see you in the next video.